Coming up next, an Astronomy.fm original program. It's time for York Universe, a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio, AFM Radio, AFM Radio, AFM Radio.
Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. I'm Dr. Elena Hyde, and I'm joined tonight by the absolutely wonderful Julie Tomei, who you have heard on this station before, I'm sure. We are broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. This is, in fact, Science Night in Canada, where the lineup is all Canadian, starting with ourselves, York Universe, and then on to Western Worlds, Quirks and Quarks, and Science for the People. York Universe broadcasts every Monday night, but not holidays, so probably not next week, at 9 p.m. local Toronto time, or a Tuesday morning at about 2 a.m. UT, if that's more your jam. The York Universe production works in concert with our online public viewing run by the amazing Observatory team. Our wonderful group of students run a YouTube show from 9 to 10 p.m. local Toronto time at this exact same time. So if you're listening to this live, that means that it's happening right now. So go on over to yorku.ca/science/observatory and follow the links to OPV, online public viewing, or just click on any of the links that say YouTube and it'll take you straight there. If you're already on YouTube, just search for the York University Allan Carswell Observatory. Our broadcast is powered by and in partnership with Astronomy.fm, the voice of astronomy. For any questions or comments about our past shows or suggestions for future topics, you can always email us at observe@yorku.ca. If you're more social media minded, you can connect with us on Twitter at York Observatory or at York Universe, and of course on Instagram with York U Observatory and Facebook at Allan Carswell Obs, just to be a little bit different. All of our programs are free, but if you would like to make a donation, you can see that website I mentioned before, yorku.ca/science/observatory. Our amazing observatory student team is right now over on YouTube monitoring the chat room for questions and posting beautiful images. Now, the current weather is a little bit cloudy, hit and miss. I'm not sure if they're able to get live imaging at the moment. If they're not able to hook up the telescope for the live images, they will be showing stock images, beautiful astrophotography, all taken from our own observatory. I'm seeing some patchy clouds and looks like the dome is closed at the moment. How is it where you are, Julie?
I am nowhere near a window, but I'm sure it's probably similar to what it is where you are. We're not that far away from one another.
Yeah, patchy clouds and changeable weather has been the rule for the springtime, which is very frustrating if you're trying to figure out if it is safe to open the dome. Always err on the side of caution if you're not sure. That's just the general rule for all of our students. But as I say, at least we were able to get some beautiful images on some of the clear nights, which we may or may not get later on tonight. Since this is, of course, an astronomy show, if you do have a peek in the clouds, just after sunset, so actually, well, now-ish actually, Venus has been really great the last couple nights. Even with the strange weather we've had, Venus has been following the sun down in the west. So if you're in Ontario, if you're in Toronto, watching the sunset, keep an eye out for a really, really bright object following down after the sun goes below the horizon. That's probably Venus. And then, of course, just above that, you've got Mars. So there's some really great, sort of bright planet watching to be seen if you do get that break in the clouds anywhere out there tonight. How about you, Julie? Do you have a favorite bright object?
I always like the planets. The planets are pretty good. Whichever ones happen to be up.
Planets are always good. I think it's safe to say we would all be pretty sad without one.
Absolutely. It's safe to say we wouldn't be here without one.
We definitely wouldn't be here. I love the literalness. And of course, if you are looking for other really bright objects, if you've got a bit of haze, you can always try looking for the Big Dipper and arcing to Arcturus. Those are some really popular bright ones. You do need a bit of gaps though for that.
I feel like the moon is being pretty bright these days.
You're right.
We're
When does
pretty
that
close to
rise
full,
again?
aren't we?
Yeah.
I don't know. Let me look it up.
What is the?
Does it make me a bad astronomer that I don't know these things off the top of my head?
Well, it has been very, very hazy, so of course, that's always a problem.
I suppose we'll call it that. Yes.
Yeah. And the hazier it is, and of course, light pollution means that you can't regularly see things as easily as you would normally, which is one of the sad parts about astronomy right now, is that it's harder for a lot of people to actually get out there and regularly see things that would have normally just been part of our daily routine. But yeah, the moon's like 60%, 70%, 70% full or so. But it's not rising until quite late, so you'll have to stay up late for that one.
Well, there you go. I know I saw it the other night.
Oh, how late were you up?
How bright it was. Well, here's the thing, right? Like, how late was I up?
Was it?
You know what?
It was
I was up
midnight.
pretty late. It's been, it's I needed a weekend to recover from my weekend. I was up late like every night on the weekend. So yeah, it was getting late. Because I went to the theater on Saturday, and that often requires going all the way downtown. So there we go. I was coming back from the theater, and that's when I looked at the moon, and it was not quite full, but it was very shiny and pretty.
Well, if you're up again after midnight, 1 a.m., 2 a.m., you should see again a very pretty moon. So that is also an excellent bright object. All right, so this is usually, let's not get too distracted by the stars that we cannot quite see. Let's go ahead and get into our regular This Week in Space and Astronomy History. So just per usual, we always like to do a little bit of a recap of what has come before around this time of year. So if I miss my guess, today is the 8th of May. Which is a nice lyrical number of day and month combo. Now, this week in space and astronomy history, I think you've got a pretty fun one for us, Julie. So why don't I hand this over to you?
Sure. So we're looking at May 13th, 1982. And this was the launch of Soyuz T5. And it was a mission to Salyut 7 space station. It was actually the first expedition crew to that space station, which was a new space station at the time. Salyut 7 was very similar to Salyut 6, but had some improvements, one being continuously available hot water, which I think was probably very appreciated. During its time in space, it received a Progress 13 resupply spacecraft, as well as visits from the T6 Soyuz and the T7 Soyuz. Cosmonauts hand-launched an amateur radio satellite. The T6 mission crew included Jean-Luc Chrétien, who was the first French person and the first Western European in space. The T7 crew included Svetlana Savitskaya, who was the first woman in space in 20 years. The T5 crew was the ones who ejected the radio satellite, and they did that through the Salyut 7 trash airlock on May 17th, 1982. And this happened before NASA launched two large geostationary satellites from STS-5 from the space shuttles in November of that year. Some people consider that to be the first launch of a satellite from space.
That's crazy. through the garbage chute.
Through the garbage chute. I mean, it was a satellite, and they launched it from a space station. So I think it counts.
I mean, I'm not sure, but like they don't have a door. Like there wasn't a normal airlock they could use, or why would they use a trash airlock? That's crazy.
I don't know. Why do they have a trash airlock? Right? Like, yeah. I guess different times. Now I don't think they have trash airlocks. They just put everything back into the Progress and just let it all burn up in the atmosphere. I don't know. Anyways, the Progress 13 delivered fuel and 300 liters of water to Salyut. And they also ran some plant experiments. There was, and I'm not a botanist, but I will try this. They were Arabidopsis plants, and they were chosen for their short 40-day life cycle. And those became the first plants to flower and produce seeds in microgravity. And all in all, the Soyuz T5 spent 6 weeks in space.
That's awesome. And I mean, I'm still wondering, like, why would you use the trash airlock? But also, what do they mean by hand launched?
I mean, you take your little satellite with your hands and you stick it in the airlock. I don't know.
Yeah. I mean, when I think of like, okay, hand
launched. It was not done with a robotic arm.
Done with a human arm. That makes sense. That makes sense. So sort of like, but so this is why we were talking about earlier. Space is actually very hard, and sometimes you do have to use not conventional methods to make things work. And of course, this being the 1980s, they were probably doing some workarounds because of their technical limitations. But it's very impressive, I think, that they got the plant growth, because that's actually become a huge thing. If you're going to go anywhere outside of Earth, you do need to be able to grow some food somehow.
Yeah. What I find interesting is like my son's class is participating in the Tomato Sphere project. And that's a super long-running project now. Are you familiar with it?
No, I've not heard of that one. Tomato Sphere?
Tomato Sphere, yeah. So
sounds awesome.
Yeah, it's run by Let's Talk Science. It used to be like an independent thing, and then I think Let's Talk Science like picked up the mantle. But it started like in the early 2000s, and classes sign up and they get sent 2 packets of seeds, and one are just like your control, and one is seeds that have been either flown on the space station or put through some sort of simulation, like space simulation conditions. And then it's blind, so like you don't know which seeds are which. It's just like, this is packet V and this is packet X. And you just have to know which seeds came out of which packet. And you see how the germination goes and how the plants grow.
Very fun.
It's really cool.
Well, it sort of reminds me of some of the projects I've heard about in terms of trying to grow seeds in soil that has been irradiated to resemble Mars soil, for example. And of course, what crops would grow and how they would survive in these other environments is of interest if you're planning on going to any of these places. So that's always good.
Yeah, I think it's a really cool way to get lots of data.
And, absolutely. And I mean, it lets kids be involved as well, which is such an important part of science. And it's when you can involve people of all ages in not just, a demonstration project, but a real project, That's always so much cooler.
Yeah.
At least I think so.
I think so too.
Well, if it was up to us. Excellent. Let's see. Now, I think I've got a little bit of a different one, not necessarily space-based, but I thought it would be fun to do a happy birthday shout out. It seems like it's been a while since we've had a happy birthday on the show. As you know, we celebrate birthdays related to all kinds of different parts of astronomy and physics. And in May 11th, on 1918, Richard Feynman was born. Richard Phillips Feynman, in fact. And if you're not familiar with Richard Feynman, he was a pretty famous theoretical physicist. He did some really amazing work in quantum mechanics and quantum electrodynamics and superfluidity and all kinds of really awesome, theoretical physics and physics concepts, a lot of which we really do use in astronomy because, of course, looking out at the universe, particle physics is immensely important. He proposed different types of models. He had the physics of superfluidity and supercooled liquid helium. So he did quite a lot of work in theoretical physics, but especially in quantum mechanics. And he actually did get the Nobel Prize, so his work was appreciated in 1965. So when he was still alive, which is always nice, and he shared a Nobel Prize with Julian Schwinger and Shinichiro Tomanga. I hope I'm saying that right. So this was a shared Nobel Prize in physics in 1965. So he also came up with some really nice ways of representing physics, and the diagrams that he created to show how subatomic particles behave and interact with each other actually became named after him. They really help you to imagine what could be going on between, electrons and protons and subatomic particles. And they're actually called now Feynman diagrams. And I had to learn about these. And it was actually a huge relief when we finally got to the Feynman diagram part of quantum mechanics, because up until that point, it was just a lot of really hard math. So if you're interested, he actually did produce a lot of his own lectures, and he was not just sort of famous for his theoretical physics contributions, and of course winning the Nobel Prize is a major achievement, but he was a sort of what we call now as an educator, a popularizer or science communicator. And he talked a lot about physics in a way that was more easy to understand. He gave a lot of lectures meant for physics students, but he also wrote a lot of books that are really, really friendly. His 3-volume publication from his undergraduate lectures actually is still very, very popular. You will find these most good libraries will have a copy, and I consider them very much recommended reading. So it's a wonderful sort of contribution to physics and also to science education because of his publications that were sort of across the board. I think probably from what I've seen, his physics lectures are the most popular, but I could be wrong. I haven't had a chance to look up which book actually sold the most. He did write a more sort of popular autobiographical book, Surely You're Joking, Mr. Feynman, and actually I haven't had a chance to read that one yet. Which is kind of funny because it's it's much more popular than the other ones that I have read. So, but yes, Feynman and Feynman diagrams, his electron positron annihilation diagrams, and showing how these subatomic particles move in a way that you could intuitively grasp once you had done the math correctly. So it's really quite remarkable. And of course, he was a very unusual person all around, living in an unusual time of the world. At one point, I believe he was investigated by the FBI. So he had a very dynamic life and made for a very popular person in the news at the time. So a lot of people have heard of Feynman. You might not have had a chance to read all of his physics lectures, but if you're considering subatomic physics of any kind and quantum mechanics, I think it's definitely a good idea. And the way that he actually went through and changed the method of physics teaching in his lectures to make it more dynamic and to really involve students more, that's something that I think a lot of us as instructors now consider the standard. But it wasn't the standard at the time he was doing it. So it's quite interesting. So that's, I think, I'll end on is that happy birthday, Feynman. He did unfortunately pass away in I believe 1987, was it? But of course, he 1988 was when he passed away, age 69, and he achieved a tremendous amount, and he obviously had just so much fun doing it. I think that it's wonderful to see people who really enjoy what they're doing, and this was one case of somebody who had a wonderful time with quantum mechanics. And I think if you're going to read any books to start off with, start with the Feynman lectures on physics, because that's a really wonderful one. So that's my book recommendation for today, as well as the happy birthday shout out.
Nice. Did I ever tell you the time that we had a Richard Feynman talk at the Physics Society?
No, when was that?
It was in 2003, 2002.
Before I got here, drat.
Yes, and we had the posters up and said, like, speaking at the meeting, Richard Feynman, and someone said, how are you going to do that? You'd have to have a seance. And it's like, yes, that's exactly it. Because of course he'd been dead for decades. Because it was the night before Halloween. And so there were a few attempts at calling his spirit to come. I was taken over by a cat. They put me in a box.
Did anyone open the box to make sure you were there?
Well, by the time they took the box away, the cat had gone, and I was back. What we did was we took clips of interviews he'd done and just like inserted our own questions.
Oh, nice.
And so it was like, so what's the afterlife like? And then, a clip from like what it was like after like they developed the atomic bomb.
Oh, nice. Yeah, so a little bit of juxtaposition there.
That sort of thing. It was a good time. It's the kind of thing that you do while you're an undergrad student and it's the night before Halloween.
Yeah, well, he is a very gifted writer. I remember reading QED, The Strange Theory of Light and Matter from him, and it's remarkably easy to read, shockingly easy to read, less easy to understand, but very good at communicating things. And of course, asking him silly questions just sounds like a wonderful idea. Did you folks record that?
There may. I think we attempted it, but for some reason it didn't work out. I don't know. It lives on in people's memories.
Well, if somebody listening to this has a recording, you can send us to us at observe at yorq.ca, and we will keep it on the archive. Excellent. Well, let's go ahead and shift gears once again.
Yes.
So we're jumping back and forth. We've done a happy birthday shout out to Richard Feynman. Let's go ahead and jump back into space with your
Space.
next one, Julie.
Sure. I'm cheating with this one because I chose it and then I realized it's last week in space. But whatever. May 7th, 1963, with the launch of Telstar 2. And Telstar 2 was a telecommunications satellite that was launched by NASA. And it was active for 2 years, though it is still in orbit because that is a thing. There are so many things still in orbit that are inactive.
Too many, you might say.
You might, yeah. I remember taking a satellite communications course at York and saying, so how many things are in orbit? And the answer being like, I don't know that anyone actually knows the answer to that. Anyways, although it was primarily a telecommunications satellite, it also carried an experiment on board, making it one of the first satellites with a, quote, hitchhiker experiment. The experiment was designed to measure the energetic proton and electron distribution in the Van Allen radiation belts. Telstar 2 was basically identical to Telstar 1, but it did have some provisions for scientific information to be transmitted in real time via the microwave telemetry system, so that the telemetry could be obtained after the 2-year timer had turned off the VHF beacon, and that beacon was turned off on May 16th, 1965, during the satellite's 4,736th orbit. A number of, so it was a telecommunications satellite for communication between North America and Europe, so transatlantic communications. And so a number of big things happened between 63 and 65. So one of them was the assassination of President Kennedy in November of 63, and so Telstar 2 brought live American television to the Soviet Union for the first time in that weekend of reporting on the assassination of the president and the mourning and the funeral that followed. In January of 65, the funeral services for Sir Winston Churchill were televised live and by delayed transmission from London via Telstar 2. And earlier that week, the pictures of Winston Churchill's body lying in state in Westminster Hall had been transmitted also via that satellite. Radiation data were collected by Telstar 2, and these enabled scientists to determine that the very high intensity electrons in the inner region of the Van Allen belt had decayed slowly during the year. It had been built a little bit with some stronger shielding than Telstar 1 against that radiation, because the Telstar 1 it was thought been disabled because of the radiation, and was equipped with specially developed transistors for to be able to better withstand the space environment. It was also orbiting in a higher apogee orbit than Telstar 1. So that made it possible for communications experiments of greater length. Ultimately, Telstar 1 and Telstar 2 were experimental satellites. These were some of the first satellites to do these transatlantic satellite communications.
Excellent. And of course, that first one getting communication over to Europe was a huge, huge deal, because before that you only had sea cables and radio, right?
Yeah.
Which was problematic. And it's hard to imagine now, especially I suppose if you're younger, just the difficulty of communicating with other people on our own planet has been, something that has only recently become easy. And it's still, there are a lot of places that, are very difficult to communicate with, but it's really opening up, and that increase of communication is good, but the number of satellites in orbit is something that is an ongoing sort of question, because of course one thing with the Telstar is they're still going, right? So Telstar is still I'm not sure if it's the exact same company, but they're still putting satellites into space. And the question of how many satellites can we fit into orbit is something that is, because most of us have heard about Starlink now launching thousands, tens of thousands of satellites. And there was an article, I think a few years ago, maybe 1 or 2 years ago, which was sort of mentioned that we're now reaching, thousands of satellites in low Earth orbit, and on the order of 40,000 satellites in mid and high Earth orbit. And so we've had things like the Hubble space satellite getting photobombed, and the risk of collision just goes higher and higher and higher. And people have been doing calculations saying, hey, we're looking at satellite conjunctions and close approaches, and of the thousands of new satellites that just Starlink has launched, Telstar has actually said that they also want to put up a new constellation of satellites. So we're now maybe in the opposite realm, where we might be getting too much coverage of some areas.
Yeah, I mean, I'm looking at a list of Telstar satellites, and there are only 19 listed here. 20 maybe. Well, okay, some of the numbers there are maybe 30.
Yeah, and that's compared
because they're
to
not
thousands.
constellations.
Yeah, exactly, and that's compared to thousands from Starlink, and now other companies also want to launch these massive, thousands to tens of thousands of constellations, and it's just like, well, that's you're going to have a debris cloud that nobody can get through.
And I don't know, like, I don't know enough about, because like constellations of satellites were not a thing we were talking about when I was taking that satellite communications course, right? Like, it was like, you want to cover an area, you either, go into geosynchronous orbit, or you pick another orbit and you go, like, depending on where you want to cover. Like, but it was always
and the amount
satellite, right?
If you just wanted Earth-wide coverage, you don't need that many satellites. And that's kind of the thing. But if you're trying to create a full constellation that's always up everywhere, then you're making a very different coverage map, and your risk of collision is way, way higher, which is a problem for things like, of course, the space station and the shuttle, and getting off of Earth and going to other planets. And of course, collisions also destroy satellites, which is never good. But yeah, at the last count I saw, they're saying 42,000 Starlinks, and OneWeb wants another 3,000, and Amazon's going for 3,000, and there's China's going system is something like 20,000. And it's like, okay, this is a lot of satellites. Like, and we did, the first ones that were up there was so useful, and we're like, wow, we have 5 satellites, we have 10 satellites, we have, what was it, 19 satellites? This is amazing. And now it's like, this seems like too much, but anyways.
Yeah. I don't know. Well, it's been a long time since I've been like on a truly like long distance transatlantic phone call. I imagine that the few seconds delay of the talking to my nonna in Italy in the early 80s is no longer a thing.
Oh yeah, yeah. I mean, I have in-laws in Europe, and we can talk with literally no delay. I mean, but that said, the space junk problem is one that everybody is going to have to address at some point.
Yeah.
And of course, there are proposals to build lasers to shoot space junk out of the sky, and that is an actual thing. They're seriously working on it in Australia.
Space lasers.
But lasers pointing up to shoot the junk down. Just knock it into the atmosphere so it burns up.
Oh my.
I mean, but I don't know what the end solution will be, but at some point,
there must be a happy medium.
exactly. And if you create too much space junk, at some point the collisions sort of become exponential, and you get a lot of little tiny pieces, and it becomes almost unavoidable sorts of collisions, and that's what you definitely don't want.
Yeah.
So hopefully we are able to come to a reasonable compromise as humans. Hope springs eternal. So speaking of constellations, I suppose. Oh gosh, actually, before I speak about constellations, I think it's about time I reminded everybody that you are in fact listening to York Universe, broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. If you are listening live and you'd like to join in on the OPV action and live chat over on YouTube, you can head over to yorku.ca/science/observatory, click on any of the YouTube links or OPV, or go to YouTube and just search for York University Allan Carswell Observatory. You can also, of course, join in with Twitter, Instagram, or Facebook at York U Observatory, at York Universe. And tonight, you're listening to Dr. Elena Hyde and Julie Tomei, and we're currently discussing, I guess, things that come up that might come down. And we are getting into all kinds of different topics. And I'm about to lead us from constellations of satellites to constellations of constellations. So I have a fun one that I found that's actually from a place that's near and dear to my heart. I was, as they say, ingeburgerd, almost, in the Netherlands a while ago. And on May 8th, 1774, there was a pretty interesting little astronomy moment in history, I should say. May 8th, 1774, in the Netherlands, and this was a long time ago. So you have to remember, we're going all over in this week in space astronomy history. 1774. So we're out of electricity. Quite a long time ago in Europe. And there was a special, what's called constellation, in quotation marks, of planets. Now, this is also called an alignment of planets. But in the early morning, Mercury, Venus, Mars, Jupiter, and the Moon were positioned very, very closely in the sky. And these were bright objects. And this was 1774. So there was very, very little light pollution, and everybody was getting a great view of these bright objects lined up close together in the sky. Obviously, I'm not counting Neptune and Uranus here, because this was they're too far, too dim, and this was too long ago. So we're looking at Mercury, Venus, Mars, Jupiter, and the Moon, all closely together in the sky. So you could see they were next to each other. And at the time, it was claimed that the mutual forces of these celestial bodies would knock the Earth off its path and cause it to be burned up by the sun. Disaster!
Everyone, clutch your pearls!
Clutch your hands, worry, pull your hair, but you could see it, and if you didn't know how far away these things were and how gravity worked, you might be worried. They're obviously close together in the sky, However, of course, that's just your apparent view. Jupiter, Mars, Mercury, and Venus are actually quite distant from the planet Earth, but they didn't look that way because, of course, how they were lined up. So the panic started in the Netherlands when it was suggested in the media that the moon and this alignment would cause Earth to be thrown from its orbit. That sounds obviously terrible, and not just thrown from its orbit, but thrown from its orbit into the sun. So this was a real worry, and people did not have a good concept of the solar system. And this is something that even in astronomy classes now, we struggle to illustrate how far away the planets are from each other and from the sun, because our concept of distance here on Earth is so skewed. But this was a real fear, and people were panicking. And there was a Dutch wool worker, Eisinga, who began construction on a large orrery, or an old-fashioned model of the solar system. And he was like, no, don't worry, I can show you this isn't a problem. And to show them, he made this beautiful, beautiful model or orrery in his living room. And it's actually still in operation today. It's the oldest working planetarium in the world, and it's open to the public. So this is pretty cool, and they do, of course, have a website. It's absolutely beautiful, and it's like on his ceiling, right? And you can look up and see where the planets are, and then they hang down, and so you can get an idea that of the distance. I mean, still not to scale accurate, because you couldn't fit that model in there if it was to scale accurate. So the orrery has been on the Dutch top 100 heritage sites for a while, and it's the oldest working orrery in the world, and it was made to combat this panic that came from not understanding what people were seeing. And it's like, no, it's not dangerous. Look, I can show you how it works, and that's just something that is just so cool, because this person was an amateur astronomer and a wool comber, and he built this beautiful, like, look at pictures online, don't believe me, go look it up, beautiful mechanical planetarium into the timber roof of the living room ceiling. And it's a beautiful house. It's one of those historic Dutch canal houses that you've probably seen on any picture that has tulips in it. But it's now basically part of a museum, and they've also included a little bit of like his some of his wool combing pieces, because that's where he actually worked, and you had other sort of 18th century things that were what he would have had access to. So Georgian telescopes, octants, a tellurium, sort of little models of the sun and the earth and the moon. And I believe back in 2018, they had a 250th anniversary of his move to the city of Franeker in 1768, before he began work on his planetarium. So they even celebrated it, him moving to the city. So it's really quite cool. And if you haven't seen orreries before, they're wonderful projects. If you're just getting started in astronomy, you can actually buy some very, very nice models, wooden models that you can put together yourself. And it's sort of usually it's done from the bottom facing up, so you have some sort of clockwork mechanism that will move the planets around a model of the sun in some sort of semi-realistic fashion. But in this case, it's upside down, and it's painted on his ceiling, and so you look up just like you would be doing in the sky. And it's all driven by a pendulum clock because, of course, clockwork mechanisms were the only mechanisms really at this time. And there's some amazing gravity-fed clockwork. Ask me about gravity batteries because they're amazing, but amazing clockwork things that have come out. And this is probably one of my favorites. And it does still work. So this is why they say it's the oldest still working. The mechanical works are in sort of the space above ceiling, and the orrery was constructed with a 1 to 1,000,000, I believe, scale, and it's really, really wonderful. So it's a wonderful educational device, I suppose, built to combat a panic at the time. And Isa was born in the Netherlands. He, most children at this time, 1744 was when he was born. He work at home. You work. You're a kid. You work where your parents are working, and so he was working in his father's wool combing. And wool combing actually did have some mechanical components in it. And he did get to study a little bit of maths, and he was, as I say, an amateur astronomer. Just a little note, the person who made this prediction of chaos and of flames for everyone was actually a preacher who was from another town, who basically sort of self-published a piece about what they called philosophical concerns about the conjunction of planets. And, the authorities attempted to sort of put the lid on the little document, but by then everyone had already gotten really, really worried. So it's another case of be careful what you read, I suppose, because you don't want to be panicking about the wrong things. All right,
Just because it's on the internet doesn't mean it's true.
Yes.
Yes. Elena, this is the coolest thing I have seen in a long time.
It's amazing, right? So if you're going to the Netherlands, all I'm saying is that like a side trip would probably be worth it.
It's worth a trip to their website, which I have put in the chat in the OPV.
Excellent.
One of the options is show current position, and you click on it, and it shows the thing. You see like the whole ceiling, and one of the options is show accelerated version, and you click on it, and you see all the little gold little knobbies moving around.
Oh, it's so
ceiling.
It's so pretty.
Going one day every few seconds, and it is so cool.
I want to build one of these in my house. New goals, build one in my house. Anyways, very, very much worth it. And of course, little special shout out to the Netherlands for having this totally awesome ceiling-based orrery. All right, so we should probably move on if we're going to do some news articles as well. But before we get there, I do have one quick reminder for everybody who is in Ontario, especially, but just generally. Exciting news are York University, Allan and Carswell special Astronomer in Residence event for 2023 is officially starting on May 15th, which I have it on good authority is next week, which means that our first Astronomer in Residence of 2023 will be going up to Killarney Provincial Park, and they will be starting off giving shows, doing talks, and doing live streams back here with us in Toronto. So huge congratulations and shout out to Bruce Waters, who's going to be the first person up this year. And of course, Julie, I know you're scheduled for later on, so we'll do your reminder later.
All good.
If anyone wants to follow along with the Astronomer in Residence, to read the blog post or to see the amazing astrophotography, it's the same website I've been telling you all along, yorku.ca/science/observatory, but then just /air, or you can click on the Astronomer in Residence button from the main website. Totally worth a peek. And after the 15th, you'll be getting live 2023 updates again. So I'm super excited.
Nice.
All right, so let's go ahead and get to some news items. There's been some really, really fun news happening right now. So we've had a great time in space and astronomy history. So let's go ahead and look at a little bit more recent stuff. Now you've got a pretty fun moon mission that you found, Julie.
Yes, well, I mean, it would have been fun.
It would have. It's an
Wow.
amazing idea.
Yeah.
Is maybe how to start it.
Yeah. So it's a privately funded Japanese moon mission, and unfortunately, it likely crashed. Communications with the Hakuto R spacecraft was lost moments before touchdown at approximately 4:40 GMT on April 25th. Engineers are currently investigating. This spacecraft was developed by the Tokyo-based iSpace. The lander, it would have released a lander called Rashid, and that lander was made by was the Emirates lunar mission. The UAE developed and built that. And there was also a tennis ball sized robot that was developed by toy maker Tomy. For any of my fellow 1980s kids, they were the makers of the Transformers. How cool is that? Anyways. Yeah, exactly. Exactly. Now this thing looked nothing like a transformer. It looked like imagine two hemispheres, but they're not solid. They have like little holes in them. So those are the wheels. And then in the center there's this little block with a camera. And like the hemispheres turn and those are the wheels. And it just kind of like drives around. It looked pretty slick. Looked nothing like a transformer. But it was made by a toy maker. It's kind of
for a non-transformer.
Yes,
it looks
pretty cool
good.
for a non-transformer. Anyways, the spacecraft was launched by SpaceX last December. It took 5 months to reach the moon. The landing site was to be in the northern hemisphere, and the payloads were supposed to analyze the soil, the geology, the atmosphere. Had it been successful, Japan would have been the fourth country to successfully land a mission on the moon. But as it stands, Hakuto R joins the Israeli Bereshit mission in the so close but didn't quite make it privately funded mission list. So the US, Russia, and China remain the three countries with successful lunar landings. Those ones are all government funded. The primary aim of the iSpace mission was to assess the viability of commercial launches to the lunar surface, and they have plans for a series of commercial landers in the next few years. The company's vision is to provide commercial services for sustained human presence on the lunar surface, such as sending up equipment for mining and producing rocket fuel. Now, there is a Canadian and even an Allan I. Carswell connection. Allan I. Carswell Observatory connection to this story. Mission Control is a software company headquartered in Ottawa that specializes in mission control software and AI, and their AI was to support the Rashid rover. So the Emirates lunar mission, as that I mentioned, was an international micro rover mission led by the Mohammed bin Rashid Space Center in the UAE, the United Arab Emirates. And the AI would have classified lunar surface features in images, and these features would have been like regolith, crater interiors and exteriors, boulders, pebbles. And the AICO connection is Dr. Melissa Battler, who worked at the observatory in the early 2000s and is Mission Control's chief science officer. And regular listeners of Astronomy.fm may also recognize her from Western Worlds.
Awesome. That is so cool. And it's, of course it's too bad that they didn't manage to land, but it, as you say, it's a huge amount of stuff that they've learned from this mission, and they did get some amazing images back. They still sent back some really nice, lunar image data, and they have one that is sort of similar to that sort of famous Earthrise photo of the moon, where they got the shadow of the moon sort of creeping over Australia during that total solar eclipse. So it's it's pretty cool. So if you're only going to get a few images, I guess getting a few really, really good ones is a good success.
Yeah. Go on.
All right, so let's go ahead and do one more quick little news item for today. So of course it's always sad when a mission doesn't make it, but sometimes they do. And this one's a little bit sort of better news, I suppose. We had fairly recently a pretty fun discovery from the red planet. So we're going from the moon to Mars, just like SpaceX hopes to do. But Mars and Martian water have been a constant source of entertainment, I suppose you should say, for scientists, for astronomers, and for anybody in planetary science especially. Martian water is, how much is it of it? Is there? Where is it? What's it doing? Can we use it safely on the surface? So there's been a lot of studies of Martian water through satellites and through looking at gullies. But I think about 10-15 days ago or so, we had a great set of activity from China's Zhurong Mars rover, which found and sent back pictures showing what they're saying is signs of recent, not billions of years ago, but more recent water activity. And so, of course, if you're not familiar with this, but the Zhurong is a Chinese rover on Mars. This was the first rover from China. It's part of the Tianwen-1 mission to Mars, which was a pretty good success, I think, all around, considering it was deployed in May 2021. It's been happily sending back data since then. It's they've had some hits and some misses, as have we all with space exploration, but the Zhurong rover on Mars, it was launched in July of 2020 and put into Martian orbit in 2021 in February, and the lander, which was carrying the rover, did a soft landing in 2021, and this was kind of a great success of Mars missions. Of course, 2021 being the great Mars, a great year for going to Mars due to its relative closeness. So since landing in 2021, Zhurong has rolled around to 4 nearby crescent-shaped dunes in Utopia, Polynesia, and they've found these really interesting, possibly water-shaped features or ridges, and they think it was as recent as maybe even within the last 400,000 years. So this is pretty recent compared to other water features, which of course were on the order of billions of years. And it's really, really great to have this coming back from Mars and from the Zhurong rover. So I definitely recommend to go and check out some of the Zhurong rover pictures, and the crust that's formed across the dunes that they've found is a really, really interesting feature, and I'm not sure I've seen the like other places. So congratulations to China's Zhurong rover. Hopefully it has many, many more years of rolling around the dunes and looking at water features. Who knows what they're going to find next. All right, so we should probably wrap up here for tonight. Mars is up in the sky, so if you are out there and you see the red planet, give a little thought to the Zhurong Mars rover and wish them luck. And everyone else, I hope you are having a wonderful evening and hope you all get clear skies. You have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been the wonderful Julie Tomei and myself, Dr. Elena Hyde. Stay tuned because it is Astronomy Night in Canada. Coming up next is Quirks and Quarks, Western World, and Science for the People. You can always connect with us on Twitter, York Universe, York U Observatory, and of course over on Facebook at Allan Carswell Obs, and check our website for show notes, content, and updates at yorku.ca/science/observatory. Thanks for tuning in to York Universe, clear skies, and have a good night.
You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.fm Radio.